All right, yeah, let's get started. We're running a little late. Are we ready to go? Yeah?
Yeah.
Okay, welcome to our session.
Yeah, welcome.
Let's start off with a quick introduction. Some of you already met us yesterday at the workshop, but just to be very complete, my name is Loek Duys. I'm a cloud architect at a small company in the Netherlands. It's called Xspirit, and well, we do mostly consultancy for Azure customers.
My name is Thissen. I'm also a cloud architect at Xspirit. We go to customers and we help them do all sorts of transformations, moving into the cloud, but also we're helping DevOps practices. And what we've learned and what we're doing on projects, we will share with you today.
Great. So, a quick tour of the agenda. So, well, we have some lessons learned for you, so you can avoid the mistakes that we made. And we will be talking about how to run a DevOps style cluster in production. You will be seeing stuff from Docker, from Kubernetes and Visual Studio, and also Azure DevOps. And we'll try to make a very complete picture for you.
Yeah, it's a little bit biased towards Microsoft technology. But I think that most of the things that you'll see you can do on other cloud platforms as well. So you don't have to use Azure, but we'll be demoing Azure and most of the other resources that are available just to make it a more complete picture.
All right, well, let's get started. So let's first consider the term DevOps for a second. I'm sure you may already know a little bit about it. So maybe can you raise hands who is doing something with DevOps in their work? Yeah, about half, I would say. Well, we've added a few DevOps building blocks to this slide. During this talk, we will cover most of them. But, well, for example, to take this one, automate everything. This means that if you want to have your team working very efficiently, they need to work together really well. So the dev and the ops obviously need to cooperate. But whenever you do something, you don't want to do it twice. So this means automate everything. If you deploy your infrastructure, make sure you script it so you can repeat it later on and you don't have to reinvent the wheel every time you do it. So during this talk, like I said, you will encounter all these terms again and well.
We will cover most of them, yeah.
Yeah. Okay.
What you want? Why do you do it? Yeah.
Yeah, why do you need it? Well, we put dev and ops together in order to make them work more efficiently together. So instead of taking your software as a developer and throwing it over the proverbial wall, you now put dev and ops together so they can work together efficiently, and the job of the developer is not done as soon as he's done coding, but the job of the team is done as soon as the software runs in production. So it's a paradigm shift as well.
Build it and run it.
Yeah.
That's what you do. So whatever you do as a developer, you put out in production, you're also taking care of it. So that usually raises the bar of the quality, because you know you as a developer, if you build stuff and it's faulty, it breaks easily, then you get the calls in the night. The website or whatever application you're building is down. So yeah.
All right, well, the way we recommend doing stuff is by doing everything with the end in mind. It's like Elon Musk, he is going towards Mars. Every step he takes along the way is one step in that direction to take him there. So when you are writing software, like I said, you want to deploy it, you want to make sure that the delivery pipeline is fully automated. And you don't do that after you write the software. No, you do that as soon as you have made your first feature. The minimum viable feature, you want to deploy that to production immediately, and you want to automate that process so you don't have to repeat that process manually yourself.
Yeah, like you said, you don't have to do everything very complete, as in all features, all whistles and bells, but do every step, but make them small at first and let them grow, so it's a complete end-to-end picture.
All right, so to support our story, we created a little demo application. It's a retro gaming application, and we've all been there probably, judging by the age. So we've been gaming on those nice arcades. And wouldn't it be nice, instead of to have that arcade hold your high score, instead have your high score posted on the internet and for all to see. So we made a web API for that and an accompanying web app for that, so you can actually see the scores, not just push the scores to a service. And obviously we made a nice front end for you to look at, and this will be our demo application.
Yeah. So we don't have the actual arcade, but just pretend that we can use the web API, and it's coming from us instead of the machines. Shall we?
Oops. Yeah. Let's look at the website in action. All right. So what you can see is a couple of high scores that are already present in the system. So maybe something has changed by now. So
maybe somebody's in your high score, so we'll refresh this page.
Okay. Well, obviously this is a little bit of a play happening here. We're not that good actors, but our web app is obviously broken now. So we need to investigate what happened.
Yes, because I'm not sure if you recognize this, but intentionally we made the high scores on our already displaying. There's a bug in the system. But now we have it's happening now. Maybe you recognize the customers calling you, telling you, the website is down. I can't do my things on the website. We would like to know that ahead of time instead of being in an uncomfortable moment chasing after bugs that you didn't know about yet. So okay. We'll go down and drill down to see, because this is when things went bad, and we need to take care of that. So first, we'll go to look at our application. We have Azure Kubernetes cluster, so it's Azure Kubernetes service that we're running. That's where our application is hosting. And your first place that you might probably go to would be to your cluster itself. And let's see if the cluster is healthy and okay. So we're using Visual Studio Code, and it has a plugin to easily set out into the Kubernetes dashboard. You just open up a tunnel, so it seems like it's going to localhost, but actually it's being forwarded to the live cluster. And we have the application running here on the DevOps Pro, and it seems to be fairly good, right?
Did you put some load on it already?
Sort of, yeah. It's here now.
Yeah. All right, so for the trained eye, there's nothing wrong here. So all the checks are green and all the dials are pointing up. So apparently everything is all right. But what we know, and you don't, is that we have limited one of our resources, the Leaderboard Web API, to use at most 1/10 of the CPU in the cluster. So what is happening here is that as far as this workload is concerned, it's using all of the CPU available to it. So we have something that is called a CPU burner, and well, obviously if your process uses a lot of CPU, it is not very performant. So even though the requests are being served, they take a long time to be served. All right, so now that we know it's maxing out, you can see it over there. It's 0.1. We only allow it 0.1, so we have a problem.
Mm-hmm. Let's go here and investigate some more. So next up, we'll go to Azure. We have our resources here in a resource room, so we have the cluster up there, and we have also instrumented our application with a lot of telemetry information. So the application itself, consisting of the web app, the web API, and the database, fairly simple stack, but it's all hooked up to application insights, which is a form of monitoring. So we can now see that there's a big spike here in the response time. Things are not looking as good, so we'll look at an application map. and see what is there.
The map is actually generated by analysis on the telemetry. So we didn't create this map, it's just there because we upload the correct telemetry. And App Insights has detected, well, it's probably a web application, and it's probably a web API, and it's able to render that for you.
Okay, let's move that a bit out. So you can actually see here that there's things taking a longer time. It's a red arrow, there's failing requests here. We've got 18, I've pressed refresh a couple of times, and we can see that there are a lot of the calls that have been cancelled, so there's failures happening. You see that this is over the past few minutes, that the failures are there, and we can, take action on the dependencies. So this is where you want to trace down, so where things are actually going wrong. So we'll take just an arbitrary one, end-to-end transaction details, and here you see that there's errors happening. So when calling the web API, there are exceptions happening. And you can see that the failed method is actually a poly retry, which is what we build in for resiliency. So the front end is actually, it can deal with the calls to the web API. If the calls don't make it doesn't crash, so there's exception handling, but it also monitors the call and doesn't allow it to take more than 1.5 seconds. It will retry a couple of times, but with those policies, it can actually be more resilient to errors. Retry it, maybe it's down for a little bit, but if the errors take longer, it will be cut off. So this is probably where things are going wrong.
So, didn't you add a new feature this morning?
Yes, we did. So this morning I added a new feature. Let's see what we will do. So this morning I created a new release. It's release 18. It's now running in production. So if we go there, we see that we have a new deployment to production. It's based on a set of code. And this is actually the code that is being used. Up here you can see that it's bill ID 147. And we could look at our cluster here and go to the pods that are running. So 147 is our cluster, and as you can see here, we're using Docker images. 147. That's the image that is running in production. So probably there is some error there. So what we'll do now is we will go back to our code and try to find the bug.
Yeah.
Will you talk us through it?
Well, we could see in the error notice in App Insights that it had something to do with the leaderboard controller, and I happen to remember that I approved a pull request this morning that was also code in the leaderboard controller. So what you can see here is that while the intention was all right here, it's just a really obvious bug, and it's only it's there intentionally. So what happens is that this limit is being decreased, but if you put 0 in as a starting number, then you go to a negative integer range all the way up to 0 again before the code continues. So this can actually take about a minute something on a regular machine. So the web API stays responsive, but every call takes like a minute to answer. So again, this is an intentional bug here, so the fix would be easy. But what we showed you was that you can trace the bug back all the way up to VSTS, Azure DevOps, in which you had a pull request and a commit, and it was all tied together. So you have complete insights into what happened. So what we can now do is file a bug for this situation, and whenever we start fixing that code later on, we can correlate the code changes, the commits, to this work item here. So everything that we do remains fully traceable in our Azure DevOps system. So the fix is quite easy. You can just remove that do while code.
Yeah, but before we do, I should make a branch, right?
Yeah. So we are good citizens here. We won't commit directly to master because, well, master is your holy branch. That is the stuff that has a continuous build on it and continuous release. So we want to protect master as good as we can. So we make our changes on a separate branch. And then later on, after the bug has been fixed, we will do a pull request and request that branch to be merged back into master. And I hope that it works as fast as I talk.
Yeah.
Great.
So I changed the code, I quickly rebuild, test it locally, but for the interest of time, we will just assume that reverting the changes will give us the original code back. Yeah. So we've done this. We will go through our changes. Let's stage these and we'll say...
If you use a hash there and include the ID of the task in the comment, it will automatically be attached to that task.
Just remember all issue numbers.
Yeah, you can paste them on afterwards as well, and that has a nice GUI for searching, but yeah. All right, so.
The branch is pushed, so it's available now on our system here.
Yeah, so we push the branch up to the remote, and that makes it available inside Azure DevOps. And now from Azure DevOps, we can do a request for the change to be merged into master. And we do that by using something that is called a pull request.
Yeah. It actually detects that we've just made one, so I can just easily create a pull request from there. I'll add Loek. Did you bring your laptop?
Yep.
Yep. Okay, so we'll add Loek as a reviewer. We need a reviewer because we don't want people fixing things or changing things and putting them in production straight away. There should always be more than one people looking at it. It might not be necessary from a compliance perspective, but if you do have to follow compliance rules and regulations, this is where you can say, you know, in configuring your pipelines and your the way you deal with your code, always make sure that somebody approves the code and that it's not yourself, because otherwise I could approve my own code. So the work item would be number 2, the timeouts that we had. It's already there, so create it. All right, so with a little bit of luck, this should be an interactive screen. I won't touch anything, but Loek should be able to see now 2 things. So on the right-hand side, you see the policies. What is happening now that we actually automatically queue a build. Because this is a pull request, it's new code, we will check with our existing build pipeline, we will check the most important parts. We will skip over the irrelevant parts because the pull request is, once it's on master, it should be okay. So you now see that Loek looked at the code and he approved it, so that's happening. And with a little bit of luck, the build will also succeed in a little bit. Once that's done, and you can have more policies, you know that the pull request with the code changes is in good shape, and it's allowed to go into the master branch. So let's see. Oh, it actually just completed. So build succeeded. Now we know that this is actually compilable code, and all the unit tests would have run if we had any unit tests. But yeah, we skipped over that part.
Yeah.
All right. So now we are. The pull request is approved, and we should be able to complete this and delete everything that we have and close the work items. So,
completing the pull request, again, this is just merging that change into the master branch. And we have defined a continuous integration build on our master branch. So that should be automatically triggered by this change now. Yeah. So the benefit of that is, again, the unit tests will be run. So if anybody else made changes in the meanwhile, they will be merged as well, and you can detect any regression by running your tests for both changes. So as soon as this build is done.
Yeah, and we're showing you the part of the build pipeline. So the things that are happening is a checkout of all your code, that's the latest sources, building it, building the images, that's build services. Now we're pushing the services, which is pushing the Docker images into the registry over and on Azure. So it's available for the cluster to download it. And then we will do in a later release. So this is all succeeding. It's in total succeeded now. All right. So the next thing.
Yeah. So the build only created a container image. Obviously, that container image is now in the container registry, but it's not running in our production environment yet. So for that, we need something that is called a release, and a release pipeline can release your container image into multiple environments. So we only have a production environment currently, but you can imagine you have a test environment too. You would put that in the same release definition and then go from stage to stage. But in order to keep it really simple, we just have one release, and that is straight into production.
We actually created 2 releases, one for the pull request, which we wouldn't need. So this is now deployed, but we need to deploy the other one as well. So let's see if this works. So this release is still the original code. Let's see if this is failed. That's okay. And we go to new release. Let's see this one. Okay. This is the one, the latest one that we need. So it's pending approval. We automatically, as soon as there's a new build, it will go to one of the stages. We only have production because otherwise it would be several steps, but you can have test, acceptance, and production also. Let's approve that. You can have multiple approvers. In this case, we didn't say that it should be not myself, but now we have it approved, and then the release should be going here. Let's see if it works.
So does this run on your hosted agent or your custom agent?
It should run on my agent here, and we might have lost connection there. So it's actually doing now running the job for me. So if we refresh this, and
Sometimes it takes a while.
yeah, let's see. It's in progress, so that's good. Okay, so it's all deployed now.
Yeah.
Succeeded. All right. That should fix the bug, right?
Yeah.
Shall we see if that actually works? So
Maybe it's nice to open the portal again, the Kubernetes portal, and see how it upgrades, because it takes a little while because of the health monitoring system, right? So if I am not mistaken, well, if you're quick enough, you should still see the error happening here. Yeah, no rush. Yeah, right. So what you see here is that the cluster obviously has received our request to upgrade our workload to the new version, but it takes some time. And you see it failing based on this liveness probe. And we have added liveness probes so we can detect if our upgraded pod is healthy before we move traffic to that new pod. So we do a continuous rolling upgrade here, and the health state of the new application is first queried, and if that returns an OK, a 200 OK, then it's time to start passing traffic to it. So instead of just pulling the plug from the old and putting it into the new, we do a controlled upgrade here. So while I was talking, this thing has automatically healed. So if we now go to the browser,
and we see that the new image is actually there from our build.
yeah, great, yeah. So yeah, still good.
Let's take this one. This was the broken one.
Yeah. And well, the web API is still starting up, so the front end may need 1 or 2 retries to get its answer again. And usually,
yeah. What we can show in the meantime is that we can also go to the backend. So that's a web API. And we can just check individually for the web API. You see it's still bootstrapping because it needs to seed some data into the database that we have. But we can give this a run as well, try it out from here. And that should be, these are the high scores, so with that we should see if we go to the home page again that it's actually fixed.
Nice.
We've done it.
Yeah. So we introduced the bug in the system, and we showed you a completely managed way of fixing that bug. So with full traceability.
Yes. So we started with the monitoring and all the telemetry, so we can see what is happening. We're not flying in the blind. We can trace back from the code, so the release that we had, all the way to the code changes with the builds and the commits. We have the health endpoints to help us with seeing if the application is okay. And we can explain this as well.
Yeah, so this is all nice, and you saw us testing in production, and obviously that may not be something you really want in real life. So imagine our application, and in production this uses an Azure SQL database. It doesn't, but it could use a service bus to interact with other systems. It may be interacting with a Redis cache, which is also a distributed system somewhere else. And obviously, yeah, great. It may send out some information to webhooks. But if you bring all that stuff to your laptop, then you would end up with every developer requiring its own SQL database and its own queue, because otherwise people will steal your messages. You will need a Redis cache somewhere in the cloud, and well, from a cost perspective and a usability perspective, this may not be very desirable. So what you can do instead is introduce a layer of abstraction, and instead of relying on an Azure service, you can decide at test time that you want to use a different one. So for example, instead of directly targeting Azure SQL, you can also run SQL Server in a container nowadays. So what if you decide at runtime, I am either in a test environment, so I will use a containerized version of my database, or I'm in a production environment, so I will use the actual SQL Server one. Well, you can apply the same trick to Service Bus and replace it with something like RabbitMQ, which is an open source queuing system, which offers similar functionality. And likewise, you can transpose Redis cache for Azure cache. Well, by doing that, you have cut away the direct dependencies to stuff running in the cloud, and you can now run your system isolated. And that doesn't just work for your laptop, it also works for your test environments. So you can have dedicated servers running multiple test environments, all isolated from each other, and all running continuous integration tests for you. That could help introduce such a regression bug as we just saw happening here. Well, a couple of useful patterns here are dependency injection, of course. By that means you can determine at runtime which way to go. And for the webhook, well, obviously a webhook is an external system that you cannot likely fake. So instead of calling out to a webhook, you just introduce a component that says, yeah, I just did that for you, while in fact it was just a stub that did nothing. Okay, well.
Yeah, we went from the inner loop. This is where you can use for local isolated development, no strings attached. You can do that while sitting in the bus, no internet connection. And we showed you the outer loop because we want to go to our cluster on the other end. That's where we want to run. We need this automate everything approach. So we took it from Git source control, but you can use any versioning system that you have. Use the continuous integration build that automatically started doing things, first up on a pull request and then finally on master. It will push the images to the container registry, and the release pipeline will instruct the cluster to pull the images into the running deployments. You can do more in your cluster, and we will tell you about agents and bots in a second, but the telemetry information gave us some feedback. And allow us to monitor the solution. You can do more than just monitoring the health and the performance characteristics of your application. You could also see if which features are being used or not being used. So if you introduce some new search feature with a checkbox that the business said, this is really cool, they will use it, and the feedback can be people are not even checking the box ever. So that gives you some which features are used, which is another type of agile and
automate your code and your build and release pipelines for the binaries that you're producing, but you can also do that for your infrastructure. We're not going to get into much detail here, but we have this release pipeline for infrastructure, and we added that.
So instead of treating our infrastructure as something that is for another discipline, like the ops people need to do that, we just define our infrastructure using code. And the code in this case is just an ARM template, which is an Azure Resource Manager template, and it defines the way we need our infrastructure to look. And that is just a file, and we can put that file in source control, and we can apply code reviews on it. So our infrastructure can be audited by people looking just at the file. And if we deploy that file, which results in the creation of infrastructure in Azure, then you don't even need to look at the infrastructure in Azure, because the file is the only definition of what will be created for you. And by doing so, we can have the 4I principle on our infrastructure just as our code.
Yeah, and you know, in case of Azure, it's ARM templates, it's Cloud Foundry, there's all types of ways of doing that.
Well, wouldn't it be nice to have something like R2D2 as part of your DevOps team, and performing all kinds of nasty tasks for you that you did once because you had to, but then you automate it so you don't have to do it ever again. So for example, you can have that bot help you with doing database migrations. It could help you for these tasks that you do not do very often, like employee onboarding, just as an example. It may take too much time to actually generate the UI for that. So wouldn't it be nice if you could just talk to something that is called a bot and have that perform the task for you? Well, it turns out that is quite simple nowadays. So for example, you can use a Slack bot. Slack is a chat app, and Slack is a chat app, and it comes with a bot framework, which allows you to run a conversation party in your Slack application, and it will be able to execute commands for you. So you send it a bit of text, like we did right there, and the bot can respond by performing an action for you. And obviously, it can also respond with text if you are doing the wrong thing by helping you. So every task that you don't want to generate a user interface for, or a separate PowerShell script which may get lost, why not move it to a bot? And the additional upside of this is that it becomes collaborative. So this chat app, every team member can access this chat app. So if there's a problem, probably every team member gets involved. And because every team member uses the same channel and talks to the same bot, you can see what your team members already tried. So if you want to do a migration, but your team member, your colleague just did it 2 minutes ago, it may not be very useful. And obviously you can also just chat with your team members in the same channel as with the bot.
I think that this will also really help out if you have distributed teams, different time zones, that you can have the full history there. The examples shown here are instructions to the bot, do this for me, but you can do more stuff there. Okay?
Yep. So, to round everything off, these are the tools that you are likely to use in a DevOps situation.
We've covered all of them. The slides will be available, so we just highlighted some of the things that we use to implement the building blocks. It's up to you to do something similar with your application, your platform, and it could be something else other than the Microsoft platform. But we found that it is very useful. There are some practices there like the resilience. That's more of a development side of things. And there's the way we work with the code, with automating everything, containerizing everything. That is our full story from end to end. We started with the end in mind, so this is where we wanted to head to. We did everything along the way. And now it's up to you, because you get to ask some questions. So let's see if we can go there for the questions there. let's see if this is actually able to. Yeah. So send in your questions that you have them or ask them out loud.
We have a live question.
Hello. I saw that you have as Windows containers and as Linux containers simultaneously in your cluster. How do you do this? Do you have some nodes for Windows containers and also nodes for Linux containers in your cluster?
That would be the way. We do not have that at this time. But the way to do it would be to add separate nodes, and in about a year or so, Windows Server will support a feature of running native Linux containers. But then the orchestrators need to catch up first, so it would take probably a year or so before you can do this without having different node types in the same cluster. Yeah.
Other questions? Yes. There it is.
Automated secrets in your set in production. And I saw in your Kubernetes you use the Kubernetes secrets, but how you change it?
Yeah. Okay. I think we can show that by using the ACR secret.
Yes, we can do it from the deployment file. So this is our deployment file. What we do is things like this. So we use cluster secrets, and from our deployment files, this is the source code that we use to deploy it. But you can see that the application instrumentation key is referred to as a secret. So we first store the secrets inside of our cluster, and the cluster will be able to see here that it needs to get it from secrets. That's one way of doing it. The other way is that things that are secret are actually placeholders. And from the release pipeline, we go to the releases quickly. We intentionally left it open, but if we go here and we do edit, we can see that we have variables with all of these things here. Those are the replacement values. And in the case of the secret, you would do this. Block it, and it's gone. So you once need to stick it in there, block it so it's now no longer available, and then you have your secret stored safe as well. The best way would be to eliminate all secrets altogether, and you could do it in some cases. So, for example, this client ID and secret are using a password. You could do that as a service account and access under that identity, and you don't need them at all anymore. But there will probably be secrets somewhere, so it's either from variables in your build pipeline and lock them, or you put them in your cluster and read them from there by the cluster once you deploy.
How do you track changes in these secrets?
Sorry, could you repeat?
How do you track history to review what changes that you made?
Okay, so the question is, how do you reveal the secrets again?
Track changes.
Track changes.
Track changes.
Somebody changed the password before.
Yes, okay. So in the case of this pipeline here, there's a history of the changes to the pipeline that are being made. And if you go to, so here's the history, yeah. So you can see who did what changes and what updates. And if you go to your cluster, or your resources, you can actually, in this case, we're storing secrets in the key vault. And the key vault, if you have secrets, and we have the secrets, for example, for the connection string, you can actually see that there is a history. You create new versions of it, so we will also keep a history of that.
And how does this history relate to changes of code history?
How does it relate to changes in code?
Yes, or are they unrelated?
Yeah, well, the way I see it is that this is not related to code because it's configuration. You change the secrets as being configuration with the same code, or vice versa. Change the code and keep the secrets the same.
Yeah. I don't see a direct relationship with code as well.
Any other questions? Okay, well, thank you very much for your attention, and have a great afternoon.